Hi, I'm John Molini, manager of the Art Packing Department here at the Art Institute of Chicago. Brent Powell was kind enough to invite me out to participate in this conference to speak about crating. Unfortunately, because of scheduling, I could not make it, so we came upon the idea that I would do a short film here to show you. Now, what we're going to do today is talk about the type of crates that we build here at the Art Institute. We'll go into some of the reasoning why, the type of materials we use and how we apply them, and the theories behind it. One thing we do here is we do a lot of exhibition crating. So over the years, we'd have to come up with different ways of accessing. And that's one of the points I'm going to try and make today. Not just the application of the materials and construction methods, but that we always think about accessing. We have two prime directives that kind of govern the way we go about our business. One is we always build from the object out, and two, we always think about the people on the other end who have to handle and unpack. So we try to keep it really simple. If you're ever familiar with some of the crates that we send out, you'll always notice that the one thing that's common is very few moving parts, minimum amount of instruction, and easy to get in, easy to get out, one way in, one way out. So the first thing we're going to start with is a typical painting crate. We're just going to concentrate here on two-dimensional. We're going to start with a painting, flat right works on paper, and then we'll work our way to a pastel. And you'll see that the foam is always applied the same way, and there's certain consistencies in the way this happens and the thought process. Now, this is a typical Art Institute painting case. It's called tandem writing, box within a box. Tandem writing because the piece and all the packing and the crate itself ride in tandem as one. So here you go. We always have an inner box, that little envelope for the condition report, because we don't always send couriers. And if you'll notice, we use ethafoam corners, and on the inside, we mirror the pads. This pad goes to the frame, this pad comes to the lid. When it comes down, provides nice, even pressure. The other thing we do is in our inner boxes, as you can see, we put Velara on all our inner pads. And the inside of the boxes are lined with a half-inch honeycomb corrugate, and that's faced with 3/16" Corex or Coroplast. And we also sink our lids as we do with our outside crates lid. Now, the reason that we line our inner box with Coroplast is to eliminate wrapping. Now, as everybody knows, or maybe you don't, the reason that you wrap paintings isn't so much to keep them clean, but to maintain and create a microenvironment so that as the temperature changes and you start having RH and moisture exchanges, it always remains the same, as Dr. Marion Mecklenburg proved in Art in Transit in 1990, so that whatever moisture is exuded by the piece, the same amount is taken in. In this particular case, this was a panel painting, so we lined the inner box with a half-inch of ethafoam to provide us with insulation. When I got back from Art in Transit in the 90s, I started experimenting with all the recommended insulating materials that were there. Polyurethane planks, etc., etc. They were all hard to work with, and they were dusted, created a lot of debris. So just out of curiosity, I lined the crate one day with ethafoam, put a reader in it, stuck it in our cold storage in photography, and to my amazement, we had a fluctuation over 72 hours of about 5 to 6 degrees. So when we need some extra insulation, we put a half-inch of ethafoam in. You'll see we do the same thing in our pastel crates, and we do the same thing in some of our inner boxes for our 3D objects. Now, we do get some insulation anyway from the crate itself, but then this half-inch honeycomb corrugate that we use gives us some insulation also. Now, people over the years have argued that you need to insulate every crate. When I first started in the business 25, 27 years ago, insulating and wrapping objects was important because we didn't have a lot of climate-controlled trucks. We were using AC ply, et cetera, We've gone a long way since then. As you can see also, we just put corner pads to support it. We mimic it with the other corner pads so that it all rides in tandem. The box is just tight enough and the piece fits in there tight. Now the other thing I want to say is that over the years we address our pads by locks and loads. And what I mean is that the pads on the bottom are your load-bearing pads, and they provide your primary vibration absorption and a little bit of that shock that comes from coming off dollies, et cetera. And then these are our lock pads. Now the reason we call these locks is because they lock everything in. Years ago I did a topple test and proved that it's all about fit. It's not so much materials, it's about fit, so we like to lock stuff in tight enough where it's snug, but not so tight that you have to yank the piece out and risk breaking something. As you can see also, we've insulated the top. So as you can see, this is just a typical AIC painting crate. Now we're going to move over here to a flat ride that we use for all our works on paper, unless they're really big, and we realize that sometimes having too big of a flat ride doesn't work because we risk having the glazing plexi flop up and down. So we'll work with the conservators to address the hinging and mounting so that we can go upright. But 90% of the time we are doing flat rides, and that's to protect the hinges on a lot of these works. And again, you can notice it kind of mirrors. If you didn't know any different, if the feet weren't on the bottom and the arrows would tell you, you would think it's the same thing. As I said before, we always do it the same way. We try to be consistent and simple. Again, you just would open this up, and as you can see, here was a piece that we had retrofitted this crate and added a smaller piece by using Ethafoam to glue it in, but it's the same thing. It doesn't matter that the piece is a little smaller than the inner box, because this foam out here, which is our main absorption for shock and vibration, is doing its job with the outer box. We use an inner box, we use an inner box so that we're not just foaming the piece and then have the crate. We can go in here, do lock, our load, keep it in, and allow a nice flat surface of here so that we get the most out of the foam that we're using, which is Ethafoam 220, which is rated at 220, 2 pounds per square inch, 440, 4 pounds per square inch. On heavier paintings, heavier pieces underneath, you will find 440 in our crates, and the rest will be 220. Again, this is a single. Now, if you have multiples, there's two ways you can do it. The two materials that people use for dividing in trays, the most common is foam board. It'll either be all the same size as divider, or you can take Ethafoam or whatever foam you're using, adhere it to this, fit it accordingly, a standard size. They stack on top, and you always put the smallest on the bottom because that's you have more foam. Work your way up to the largest, because the largest piece or the two largest dimensions will dictate how big your crate will be. Another material that we use, and I've been playing with for a long time, is Corex or Coroplast. All it is corrugated plastic. It's cardboard. It's made out of plastic. We'll use this as dividers when all the pieces are the same size. Now, as a rule, when we reduce stacks, we try to keep the crate underneath 24 inches because after that it gets a little awkward for people to dream all the way back. As you can see, we mark it, we plate it, we double gasket all our crates. We don't sink the plates. We just put them on there and allow the gasket to go over to give us a nice seal. And as you can see, we always sink our crates because we use a lap joint on the sides in this way. We like to sink the lids in both the inner boxes and the outer crates is so that if there is some incident where water comes through, it makes it harder for the water to make its way in. Again, years ago we did a soak test. Jesse Spite, a good friend from Indianapolis, was kind enough to do it, and I believe we presented the results in Atlanta, and it showed that Crates built with a sunken lid. It took a lot longer for the water to get in. And crates that had an inner box with the ethafoam took longer for the water to fill up, whereas when we had a standard lid on top of the side wall filled with polyester, it just acted like a sponge. Both materials work, by the way, I want to say, polyester and ethafoam. Now, we're going to move over here to a crate that the AIC is known for, a crate that I helped design. And this is a pastel crate. Now, as you can see, we paint our crates and paint them, etc. We put a nice P on there to let people know that it's a pastel crate. We also must write flat. And you'll see our crates will always say use a pallet jack to move, because the system is basically an inner box and a crate within a crate. And we don't want people lifting these crates up all the time. This one has handles on it in case something happened, but our larger ones won't, and we make them the feet double so that you can get a pallet jack under there. Again, you can see ethafoam used sparingly in the corners to lock in and do our work as locking, absorbing some of that side shock that happens. 1 inch in between, you notice our other crates standard with 2 inches. Well, when I built the prototype and sent it to the National Gallery in London to travel around Europe with accelerometers on it and all kinds of devices, we came back and the only adjustment that we had to make was putting 1 inch foam between the two shelves, because that worked really well. Again, the lid comes down, hits these pads. This lid comes down, hits these pads, and then here is what we call the primary pastel carrier. Now, years ago, we had made it so that you could take the pastel carrier out to where you wanted to do your examination. But we found out that it was really important that the primary pastel carrier, or this inner box, be as tight as it possibly could so that we would get the most absorption out of our, meet the cushioning curves of the foam. And again, this is no different than that box and that box, except here you can see we always insulate the pastels because the conservators feel that that's very important, especially with such a delicate medium. Another type of crate that we use here at the Art Institute for certain works, some of them are very large, some medium-sized like this, that we feel are too heavy because of the glazing or the nature of the works, are end loaders. You don't see a lot of these like you used to, but they're still very popular in Europe. Now, pretty easy. You make a traveling frame. You can make an inner travel collar, as you call it, or a traveling frame that's faced on either side, and it merely slides in and out. Instead of laying this big crate down, you can just pull this piece out. Now, Mike here is going to help me see one of the things that over the years we've realized that a lot of times you go to pull these puppies out, and they don't have any kind of handles on the end. And they also don't have on the side. So one of the adjustments that we made to make it easier for people on the other side and prevent the drop as it comes out and not have to take our lid and engineer pads, or on one, we saw a few crates that had drawbridges. We just make it so that as you pull this out, you can see here, we just run a pine handle that goes all the way down so that we can just safely lay it down like this and not have it drop the end, drop out. Now, if you can see, the camera can pick this up. It's very simple. Because again, you'll see we sink our lids like we always do. And one of the reasons that we sink our lids also, forgot to mention earlier, isn't just to give us better water protection, but because we use MDO, two-sided. And when you have an MDO lid sitting right upright, you're exposing the ply to water, so if water were to come down, it would compromise and basically negate the waterproofing. So to take advantage of that material and also give us more strength in our lids and our crates and water protection, we sink the lid. As you can see, simple. These are our guides, and our lock slides in. Underneath is masonite we use. You can use 1/2 inch, one-sided MDO, it's nice and papered. And underneath, if you can see this, is that because Ethafoam is not manufactured to use in full sheets, you can see we just use 1 inch underneath there and space it so that we get the most out of the cushioning curves. Now, you can see that this looks very durable, and it is. And this is also a good time for me to explain that this is basically not just a collar frame faced with Coroplast or Corex, but it also falls in the category of a crate that we came up with, that we designed, that we basically call a hybrid. So Mike here and I, we're going to take the list. You can see we make the corners so you can use that to take it off. And then we're just going to stand it up here. And again, this was a work on paper that need to be insulated. We insulated this, added our foam. And again, you can see these are the lock pads. But underneath here, these pads are 440. The reason we started using 440 underneath is that we noticed that we started to have what's called a little bit of compression creep when we had either sharply beaded frames or pieces would be glazed with Amaran, which is a shatterproof glass, which is very heavy. So we realized if we started that with 440, we'd have less compression creep and therefore not opening the space and then finding a little rubbing on these pads. So you can see that. And again, you can see it's the same thing. Sunken lid, double gasketed, etc., etc. Now, I mentioned the hybrid, and that's what we build in really big cases, and maybe if we have a chance, we'll move the camera up to the front of my shop and we'll just pull out a big hybrid that goes to our Kayabot Rainy Day Paris, and I'll tell you why we do that. But if Mike will help me hold this kind of at an angle here. You got there, Mike? I just wanted to show you this profile. This is a hybrid because we use wood, and then we use corrugate 1/2-inch honeycomb, and we also use the Coroplast. And what we do is we have 2 layers on the outside, red, because those are our colors, and if you take the fluting and you rub and you cross-flute it, just like in cardboard boxes, you get a lot of strength. And then to help it give us more strength and give us harder to get through puncture, and also provide some insulation, we put the 1/2-inch honeycomb, and then there's 2 more sheets of Coroplast that are white that we have on the inside. We use white on the inside basically because then if there's any frame loss, any frass, anything like that, we can see it immediately. Again, by lining this with foam, lining our hybrids with the Coroplast, there's no reason to wrap this piece. Again, if you had to wrap this piece, what would you have to do? Lay the plastic out on a table, turn the piece face over, plastic hits the floor, picks up dirt, comes in. So this is what we call a hybrid, and this is our version of a travel frame inner collar. If we wanted to, and we have, if this piece was going on an exclusive truck, one venue from here to New York, here to St. Louis, here to LA and back, instead of a big crate with an inner box that would just increase the size exponentially, we'll just make a hybrid like this. We've tested these. They're bug-proof. They're waterproof. We even did some puncture tests on it where I took a claw hammer and swung as hard as I could clawing down. Couldn't puncture it. Another time, Mike got on the forklift. We took one of these, put it up against the wall, brought the forks up, drove into it at about, not a real fast speed, but pretty much what you'd see. The tips gouged this, but didn't go all the way through. And in fact, when we brought it away, it hit it and knocked it down. The one last thing I want to talk about with paintings is ozclipping. A lot of people do it, and everybody has different methods. One of the methods that we came up with, because we're never big fans of the threaded post with the butterfly, because it's so hard to get your hand in there. I have big hands, and it's usually an inch, inch and a half away, and you get the little nutty buddy in there, and they always slip. The other thing, a lot of times those threaded posts would fall. You know, one day we were just playing around trying to figure out a way that we could maybe do this a little simpler for the art and for the other people involved, you know, because we thought instead of just complaining, we see what we could do. So I just want to show you how we ozclip here and some of the reasons why we do it. And what we do is basically, this is a bolt closure system that we use. You find many crates. What we do is we use the receiving end. Again, we make an inner box. This is an actual inner box from a Mondrian that goes out every once in a while that we saved. We just rebuild a shell. Again, it's typical AIC, inner box construction, coroplast, honeycomb, foam board, coroplast, held together with plastic binding screws. You can buy from MasterCard, which is a male and a female. You just get them up in there, tap them together instead of trying to hot glue everything. Tape the edges so we don't have any dusting, and also to help cut down the deterioration of the styrene will off-gas and eventually break down. Even though it's short term, we do sometimes make boxes for storage that will utilize this. So again, you could see, well, even though we ozclip, we always have a safety pad up on top that doesn't touch the canvas, stays above it, because you never know when something might happen. It might fall over. You know, ozclips are rated at about 1,000 pounds, I'm pretty sure, on the swivel. Here we have an ozclip. Ozclips, because they're invented by a guy by the name of Neil Wilson down in Australia. This is one that has a D-ring attached to it. And basically, you know how this works. This would be attached to the back of the canvas on the stretcher. This would go to the crate. When you take the painting out, you can just fold that up, hang it flat to the wall. Now, as you can see, there's only about 2 inches between the edge of here and your receiving hole where usually that threaded post would come through. Well, this is the back of the canvas. Usually you're going to, back of the stretcher, you're usually going to be about here. So that doesn't leave you much room. And that's what I mean about trying to get in there. So what we did is we realized that, you know, we decided to experiment, and what we did is we came up with this system. And I'll stand this up for you so you can see. And what we do is we've done a couple things, modifications. First of all, the other thing that I never understood was you basically would be, a lot of times, you're ozclipping paintings into big travel frames. You're ozclipping the painting directly to the wood of the travel frame. Okay? First of all, wood is a great conductor of vibration. Anybody who takes speakers and puts them on the floor, you can feel the bass the other side of the room. It's the same thing with paintings, same thing with art. We put pads that will go underneath, provide some cushioning, and just using some simple 1x pine, this is just 1x4s cut down to the same height. That's 3/4 plus this 3/16 is a 1/16 less than an inch. This is an inch, but the idea is so that when we bolt it in, it comes against the padding. It's got cushioning inside the inner box as they're taking this. Again, if this was a travel frame, I ask you to use your imagination. You're moving it around. You've got some cushioning instead of just a raw piece. And we put pads in here to act as guides to help people as a visual aid as they're going down so they know where they can aim the corners. This does not touch the canvas. It's usually an 1/8, 3/8 an inch off. The painting would be just come right down, guide it in. You just get your hand in there because the edge of the painting is going to be up in here somewhere. Okay, so you have about 1 inch to start it, and then you come down and tighten it up, and that's more than enough. We've never had any failure. The same thinking that we apply to our two-dimensional objects, we apply to our three-dimensional objects, and that is we build from the object out all the time, custom fit everything in that. We keep the moving parts to a minimum so that the person on the other line doesn't have to wrap, figure it out. It's all labeled. It's all very simple. We include instructions, and we'll also identify pieces. So this is a box that we built for a small vase that I saved, and we got rid of the crate. And as you can see, this box is made out of foam board. Again, the Corex back and front with foam board line. As you can see, again, like everything else, it has the coroplast and the pads. And the one thing I really like about Ethafoam, and I'm sure people who have worked with a lot will agree, is that it's a great material to work with. Here, we just had a real simple rock vase that went in there, and all we had to do was talk with the conservators, figure out where we could touch it, and all we did was cut this, and you can see what the shape is. So now, when it got to where it was going, they have an option at the destination. They could reach in, take this box out, put it down. Instead of being on the floor, they could take this, put it upright where it's safe on a table, open it up, when we wear gloves, and you could just reach in and grab the thickest, best part, instead of a cavity pack that has Tyvek or whatever, which works, Piesman. So reach in. Here, you can just reach out. It doesn't matter. It goes in. If this was a vase or a pitcher that had a handle or some kind of ornate work on it, we would cut the foam accordingly. All right? And we cut this on a bandsaw, or you can use a really sharp vegetable knife. People use all kinds of different blades. And that's what I like about it. Little 1/8" Velara. Now you can get Velara in different densities also. This is 220. We will use down here. This is a little piece of 440. We just wanted it had a little weight, lined with coroplast. Very simple. Here you can see. Tells you just, hey, wear gloves, put it in, one way out. And this would be in a crate that, again, would have 2 inches around it, all locked in, riding in tandem. No matter how big a piece is, from this small, I'll show you a gaming set in here, to very large sculptures, we always do the same thing. We use enough material to lock it in, enough to provide us with the ample cushioning curves, and also allow space for people to get in there and move. The gaming set, here's our one piece work, the little boxes with some of the pieces. This was another box that had some of the gaming set in it. And then underneath here, was the gaming pieces themselves that you could take this out instead of reaching in and handling each individual piece, picking it out of a cavity pack. All you have here is you could take this on the table. We use Velcro, a belt that's attached. So here you can see. So all these little porcelain gaming pieces on their sides went in here. We did a really large loan of large Japanese screens. Instead of making big, large crates that were going to be insulated and had to be laid down, and then you had to pick up the screen flat and then muscle it up to take it, we decided to take a little different approach, and approach it like we do whenever we pack mirrors, we've packed tabletops, etc., and that is always leave them up as long as you can. If you were to get a crate from us that contains glass, a window, a mirror, we wouldn't make it so that you lay it down, because that's the worst thing you want to do. We'd always try and make it so it stands up and then break away so that you can get to it. Besides that, this is also the prototype for this. It also shows you the type of crates that we make when what we call breakaways. We don't have all 6 sides here come apart and then you have to put them back together separately. Anybody who's ever done that understands. Whether you're bolting them or screwing together, they always are hard to get back together, because a lot of times when you lend things to exhibitions and they're in true breakaways where every piece breaks away, the tendency is to take the crates and put them in storage broken down. Now, if you're on site and you have HVAC, climate control in your crate storage, all right. But if you're a museum that sends stuff off-site, well, it's not always the best, and things can warp and make it really hard. And that's speaking from experience. So this is the prototype for the Japanese screens, and we'll also show you. A typical AIC breakaway that you're going to see here and see here works like this. First of all, the top comes off. And here you can see in the Japanese screen crate, we glued in all the foam, fitted, contoured for the screens that were going to be in these blue board boxes, all glued in, lined with Velara. You would just take this off. And then the next thing that comes off would be the front. And here you can see my models that we made that represent the screens. And we can just pick it up and slide this away. And then what you have are the screens sitting right there so that when you want to unload them, take them out, repack them, unpack them, an individual will be there, I'd be here. You can get your hands underneath. You can get a nice safe grip, pick it up, take it to where you want to go, table it, stand it up, etc. Same thing when you go to repack it. Instead of coming like this and dropping a crate, then pick the whole crate up, especially if you have multiples and they're very heavy. Well, two guys just come here, put this here, right? Just come back when you want to repack it. You can see how these inner walls, and we did type of crates we made hybrids because we wanted to keep the weight down. That's one of the reasons that we do this also, is that we want to keep the weight down a lot of times. Instead of having a 600-pound crate, we can have something that provides us with all the protection and humidity, temperature control, insulation that we need, and keep the weight down so they're easier to handle. So it'd be the same thing. You just do it in reverse. The three sides come here. You would just put the front here, bolt it all together. Two guys come. We line it up. We always have our orientation corner. It will just come all in here, and there you go. Very simple. A lot different than laying stuff down and trying to get it up. Now, last thing I'm going to show you is this is an actual loan crate that's going to be going out in a couple weeks. And it's a chair that's going to travel to a number of venues. So we put it in a wooden crate. It's going escorted. Now, it's the same thing. It's the basic same premise. Here you can see you unbolt the top, and there would be instructions telling you that. And this comes away. Put this over here. This, now you come and remove this, and as you can see on the inside of this crate, we wanted some insulation, so we put our half-inch honeycomb in there. The conservators said we didn't need to line it with foam because it was going to go right out our door immediately on the HVAC truck, travel, etc., etc. We were cool. We know from testing that we're getting enough insulation to help protect the stuff. And as you can see, here's some 440 cut on our bandsaw, shaped, lined with Velara. This will sit on the seat, keep it in place. And again, if you can see in here that all the foam has been cut to support it, because whenever you pack furniture, you always want to take some pressure off of the legs, be it the desk, be it a chair, be it a sofa. Take some pressure off of the legs. Here you can see this comes to the sides where the seat is. Here's the other part of the seat, lifts the bottom up a bit, all glued in place, very simple. Again, the chair would still be sitting there. This slides away because it flexes a little bit. You just pull this away, and now two guys can come and take it away. As opposed to in the old days, you take the front off, and then you have to come from the sides and do the unbracing and then reach into a box and pull stuff out. Remember what I said earlier? A lot of art kind of gets a little handled more than you'd like to when you have to reach in boxes. Our pet peeve is taking fronts off and having to reach in and pull sculptures that weigh a lot, remove a ton of braces. Okay? Now, if we were in need of a brace, we would run the brace, and just the way you saw how we ozclip using our bolt plate system, that's what we would do too, so that you're not coming from here screwing, because everybody knows if this were to travel, The more you use that screw, you start out with a 2-inch, you get to a 3-inch, and then you have to start moving the brace or putting new holes, and you're compromising integrity of plywood. And here you go. Let me tilt this up, and you can see on this base, we tell you where the front is. There'll be a picture, the chair can only go that way, and here we have a little book that we made out of Corex that Sven made, and here you go, scored, folded. The book would go in there and travel with the piece, and there you go. Real simple. Just like everything we try to do, like I said, we always build from the object out, not from the box in, and we always think of the other person, right? It's part of a lecture I did years ago, and I still do when I teach at the Campbell Center. Before we even start looking at slides and look at crates, it's called who, what, when, and where. And what is it? It's just a mental checklist. Who's receiving it? What's going? Where is it going? Things that we do here has helped us why we build the hybrids, why we build breakaways, why we build the different type of crates that we use, is because we know that not every museum is like many museums that you find here in the United States. They're buildings that were specifically built for art. They have docks. They have lifts. People have forklifts. A lot of on-site crews for the most part. When you start going even out of major urban areas, it's a little different. They're in buildings maybe that weren't necessarily designed for art. When you get to Europe, it's even crazier. Hey, it's in a house. Hey, it's in a palace. Hey, it's in an old monastery. Hey, it's in a castle. Hey, you got to access it in Venice, putting it on a dolly and going up cobblestone streets. So if you have really giant wooden cases, that gets kind of crazy. With a hybrid, we can cut it down a bit and reduce the weight. All right, this is an example of how we approach three-dimensional objects. Remember, use your materials, build from the object out. Remember, the materials you have are only as good as the application. The application is only as good as the information that you get from the conservator or your familiar piece, but also part of that information is thinking about where it's going, how it's going, and who's going to unpack it. And thus, this is why we come up with all these different things. Okay, that does it for three-dimensional. Okay, folks. Last thing we're going to talk about, you heard me, is we're here at the front of my shop. These crates were so big I couldn't get them out there because we're so busy. But you heard me speaking about hybrids. And I just wanted to show you something, why we build hybrids. If you look right up here, this is a hybrid for our Caillebotte rainy day in Paris. We couldn't pull it out because we have this bar in the way. But I wanted to give you a sense of the scale we're talking about. If this was a wooden crate, and you had to lay this down, right? We all know how heavy that is. A sheet of 1/2-inch MDO two-sided comes in at about 30 pounds. The same 4x8 section of a hybrid, which is 2 pieces of Corex cross-fluted, 1/2-inch honeycomb, 2 pieces of cross-fluted, comes in at a 4x8 sheet, comes in at maybe 10 pounds. But I wanted to get an idea of the size, the scale. Now, probably somebody sitting there going, hey, well, John, why didn't you make an end loader like you did for your big Zuberon Crucifixion of Christ? Well, if we made an end loader and we were to put the Caillebotte painting in there, which itself weighs because it has a substantial frame, that would increase exponentially all the dimensions also. And then we'd have a hard time getting it in and out of the building. And not only that, getting into a truck. Another thing with a hybrid is it allows us to handle them a little easier. We don't have as much weight to go and as we're lying it down. And that's one of the reasons. I came up with this because in the late 80s, I traveled with the Kiefer show. Anybody's familiar with his work, especially at that time, it's humongous. Most of the stuff was in really big travel frames. And I remember how hard it was to move that stuff and how it was almost like mounting a siege with the equipment we had to use. But more importantly, I remember watching one time, they were handling one of these crates and it toppled. And it just took everything with it. And I remember talking afterwards with some of the people where it happened in Philly, and they were just like, had that thing been lighter We couldn't handle it. It was so hard. We couldn't control the weight. And I came back home, and like the mad scientist I am, I started experimenting with different materials. I used gator board. That was okay at the beginning. And then when I found coroplast and the honeycomb, then we started playing around to come to this point. Now, this isn't for everybody, but it is an alternative. And I think that in this day and age also, with the price of wood and the price of, transportation by dimensional weight, this keeps it down. And the other thing, when this baby's done traveling, this comes back, we can take this apart, reuse every piece of this coroplast, the honeycomb, the foam inside. Another thing I love about Ethafoam is that you can glue it in, you can take it out, you can put it on your shelf, you can use your knife, you can use a bandsaw, you can keep using it over and over and over till it's a little bit, and then you find somebody recycles it and you give them to that. Last thing I'm going to say is I hope you enjoyed this little presentation. I hope that I wasn't too long-winded or too confusing and moving too fast. Unfortunately, there's not going to be a Q&A because obviously I'm not there. But if anybody has any questions, you can always email me. And you could find me at jmolini, M-O-L-I-N-I, @artic.edu. You can call me, but that's kind of dicey. But send me an email. If you ever want specs of anything, I'd be glad to send them to you. If you have questions about anything you've seen, or you just want to discuss a packing thing, I teach at the Campbell Center. Students are always sending me questions, asking me things. Please feel free. And if you ever find yourself in Chicago and you got some time to kill, hey, give me a ring, drop me a note, come on by, and we can show you some stuff firsthand, show you some things that we do, and even give you some samples. Okay, take it easy, enjoy yourself. Bye-bye.